Hello, in this video I'm going to solve a problem for you on the topic of trigonometric identities. Let us read the problem together first. Prove the following identities: sine x to the sixth minus cosine x to the sixth over 2 sine x squared minus 1 equals to 1 minus sine x squared plus sine x to the fourth. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. Okay, now let us go to the board and solve the problem together. So I want to prove that the left-hand side of this expression is equal to the right-hand side. So what I want to use is this identity, algebraic identity, which is useful here. If I have the difference of two cubes, a to the third minus b to the third, this can be written as a minus b times a squared plus ab plus b squared. Yes? That's extremely easy to see why. For example, here, I start from the right-hand side here. I just multiply this in, so this becomes a cubed plus a squared b plus ab squared, and then I start multiplying this in, so it becomes b minus ba squared minus ab squared minus b cubed. And then you see that a squared b and a squared b with minus sign are cancelled, ab squared and ab squared are also cancelled, and a to the power of 3 minus b to the power of 3 is left, which is equal to the left-hand side. So I was able to show that the right-hand side is equal to the right-hand side. But what is this good for? Because you see, here I have 6 powers, but every 6th power can also be assumed as a third power. Yes, how? So let me just do it now. I start from the left-hand side. First, I write this in this form: sine x to the power of 2 and then to power 3. This will give me exactly sine to the 6. And then I would write the same thing for here, do the same thing here. Okay, and then divided by this expression. Minus 1. But now I give the role of a to this guy, and this one to be b. Yes? So then I have a cubed minus b cubed. So I can factorize it like this. So this becomes equal to sine squared x, because a in this case is sine x squared, minus b, which is minus cosine x squared, and then multiplied by a squared. A is sine x squared, so a squared becomes sine x to the fourth. And then I have plus a times b, which becomes plus sine x squared cosine x squared, and finally plus b squared. b is cosine squared, so b squared becomes cosine to the fourth. And then divided by 2 sine x squared minus 1. Okay, so it seems that it is not promising that much, but if you are observant enough, then you realize this expression is exactly the same expression as it is written here. Why is that? So, instead of this cosine squared, I can write 1 minus sine squared. So if you want, I can write it here for you. So let me go here. Or we can go on this board. So I want to let me write it here, yes. I want to calculate sine, I want to show that this expression is equal to that expression. How? So I would say that sine x squared minus cosine x squared is equal to, instead of cosine x squared, I write 1 minus sine x squared, yes? So cosine x squared is 1 minus sine x squared. But if I remove the pair of brackets, this becomes sine x squared minus 1 plus sine x squared, and then this one and that one will be combined, so this becomes sine x squared minus 1. So you see that there is no difference between this expression, which appears in the numerator, and this expression, which appears in the denominator. And that is also in factorized form. So this is a common factor, so the common factor can be cancelled out. Okay. Then what is left? This expression is left, but if you don't mind, let me write these two next to each other. This becomes sine x to the 4 plus cosine x to the 4 plus sine x squared cosine x squared. Okay. As you see here, I have a mixture of sine and cosine involved in this problem, but I want to have only sine on the right hand side. If you have followed my videos, in one of the previous videos, which you will find the link to that video below here in the description below this video, I found a formula for sine x to the 4th plus cosine x to the 4th. In that video, I told you that this is equal to 1 minus 2 sine x squared cosine x squared. So if you have that in your memory, so you can use that, and then you see that minus 2 sine x squared cosine x squared, and that one will be combined to minus 1. So then it becomes equal to 1 minus sine x squared cosine x squared. But still the problem is not solved, because still I have a mixture of sine and cosine, but of course simpler. I got rid of the 4th powers. Okay? But okay, I want to write everything in terms of sine. The problem is simple, so I just write 1 minus sine x squared. I keep it because I need it, but I do not need cosine x squared. So I would write it as 1 minus sine x squared. And then when I multiply this in, everything is done. So this becomes 1 minus sine x squared. This one multiplied by that one becomes positive sine x to the power of 4. And that is exactly the expression that you see on the right hand side. This becomes the right hand side. That was a little bit tricky problem, because first of all you need to have this factorization in head, and of course I am using a not very famous trigonometric identity, but I'm telling you that even if you don't remember this is a standard. This you really need to know if you want to solve harder problems. But might be you don't have this formula in your memory, but still you should be able to solve it by the same strategy we used there. Because here I have a mixture of sine and cosine, I want to get rid of all cosines. So the trick is clear. So let me just change my color and redo the problem from here in a way that you don't need to have this formula in your memory. So what I do, I copy and paste the first term, which is sine x to the 4th, but cosine x to the 4th, I don't need it. So what can I write? Instead of cosine to power 2, I can write 1 minus sine x to power 2. This will give me cosine x squared. And now if I square it once more, it becomes cosine to the 4th, which is exactly the expression that I need. So this is correct. The rest is the same. Sine is x squared, I need it, but I want to get rid of cosine. So what I write is 1 minus sine x squared. So wherever I see cosine x squared, I replace it with 1 minus sine x squared. But then this is not hard at all, because you can expand this to power 2. This becomes sine x to power 4. The first one squared, 2 times the first one times the second one. and the second one squared, which becomes positive sine x to the power of 4. And now here I multiply this in, so this becomes sine x to the power of 2. And then I multiply that, it becomes minus sine x to the power of 4. And you will start simplifying things. So, the first thing you see, this one and that one are gone. You have a 1 here, and then this one, so I should have made a mistake somewhere. Oh, no, that's correct, that's correct. It's minus 2 sine x squared, and this is plus, so it becomes minus sine x squared. So let me just repeat. This one and that one are cancelled. I wrote 1 here. This one and that one are similar. This is minus 2, this is positive 1, so if I combine them it becomes negative 1. But that also I took care of. There is one term left for me, and that is sine x to the power of 4. And again, as you see, I actually was able to get the right hand side again. Of course, if you have more identities in your head, then you will be able to probably solve the problem easier. But the price that you have already paid is to have that information in your head. But it doesn't mean that if you don't have that, you cannot solve the problem. Okay? But something like this, I really recommend you to have in your memory. I write another version of that one. If here I have the difference of cubes, you can also have the sum of two cubes. The only difference here is that this becomes a plus b. This becomes a squared. The middle term will change to negative, and then this becomes b squared. So I really recommend you to have this formula, these formulas in your head, or at least know that the sum of cubes and the difference of cubes can be factorized in these ways. Okay, so I hope that you enjoyed the video. Until the next video, be safe and goodbye. Thank you.